In the cold silence of space, countless rocks drift endlessly around the sun. To the untrained eye, they seem lifeless, barren, unremarkable. But within these wandering giants lies a treasure beyond imagination. A single asteroid, no larger than a city block, could contain more wealth than all of human history has ever extracted from Earth. This is the trillion-dollar question. What are these rocks made of, and why should we care? Today, we embark on a journey into the untapped riches of space and how they may redefine the future of civilization. Asteroids are leftovers from the birth of the solar system, ancient fragments that never formed into planets. Their surfaces may look desolate, but inside lies abundance. Some, known as M-type asteroids, are packed with nickel, cobalt, and the platinum group metals, elements so scarce on Earth that just a few dozen tons dictate entire industries. Others, the C-types, carry vast reserves of carbon compounds and water ice. In space, water isn't just life, it's fuel. Split into hydrogen and oxygen, it could power rockets far beyond Earth. On Earth, we claw these same materials out of the ground at great cost. Scarred landscapes, toxic tailings, and carbon emissions. But in the void of space, these resources float freely, waiting to be claimed. Today, humanity relies on mining that reshapes entire ecosystems. From rare earth elements for smartphones to platinum for clean energy technologies, demand is soaring, but the Earth is finite. Mining an asteroid, however, is another challenge altogether. The distances are vast. Temperatures swing from blistering heat to freezing cold. Gravity is almost non-existent. Machinery that works on Earth may simply float away. Engineers have proposed robotic harpoons, giant space nets, and autonomous drills that can anchor themselves to a tumbling rock. These ideas remain on drawing boards and in prototypes, but they are no longer science fiction. They are blueprints for humanity's next giant leap. What will make asteroid mining possible? First, propulsion. Traditional chemical rockets are too slow and too costly. Enter nuclear electric propulsion, systems that can push spacecraft across millions of kilometers with steady, efficient thrust. Solar sails may one day harness sunlight itself to chase down asteroids. Second, robotics. AI-driven machines that can operate without constant commands from Earth, adapting to unknown surfaces, drilling, anchoring, and processing in real time. And third, resource utilization. Instead of hauling everything back to Earth, imagine processing material in space, extracting metals to build orbital stations, converting asteroid water into rocket propellant. This is in-situ resource utilization, and it changes everything. Why does this matter? Because asteroid mining could spark an entirely new economy. Imagine launch costs dropping because spacecraft no longer need to carry all their fuel from Earth. Imagine industries building habitats, satellites, and space stations entirely from off-world resources. A single M-type asteroid could contain trillions of dollars in platinum. That wealth could dwarf entire national economies. But with that potential comes new challenges. Who owns the riches of space? What laws govern the extraction of resources beyond Earth? Already treaties exist. The Outer Space Treaty of 1967, declaring space the province of all mankind. But as nations and private companies eye these riches, regulation, ethics, and cooperation will determine whether asteroid mining becomes a new gold rush or a carefully managed step toward abundance. Asteroid mining isn't just about wealth, it's about possibility. Water ice from asteroids could sustain lunar bases, shielding astronauts from dependence on Earth. Fuel depots orbiting Earth could resupply missions to Mars. Metals harvested in space could construct massive orbital habitats, entire cities floating above the Earth, powered by the sun. From these building blocks, humanity could move outward, first to the moon, then Mars, and one day beyond. Instead of exhausting Earth's finite reserves, we preserve them, while building a civilization that stretches across the solar system. For all of history, humanity has lived in a world of scarcity. Wars have been fought over resources, nations divided by access to wealth. But space offers a different path. Asteroid mining represents a profound shift, from scarcity to abundance, from extracting the last drops of Earth's treasures to embracing the endless frontier of the cosmos. It will not be easy. The challenges are immense. but the rewards are nothing less than the survival and flourishing of our species. We stand at the edge of a new era, one where humanity is no longer bound to a single fragile planet, but empowered by the limitless resources of the stars. The question is not if asteroid mining will happen, but when and who will lead the way. This isn't science fiction. This is the next chapter of our civilization, and it begins out there.